So I see you've already written down your learning goal. I can divide and explain using 2-digit division and 4-digit dividend. So I wanted to practice a little bit of math with you today. I've given you a problem on your desk. And this problem says, Marcia has 480 stamps in her stamp collection. She wants to split them evenly in the boxes of 32. How many boxes of stamps will she have? Take about 20 seconds. I want you to evaluate the problem. Have you finished? Go ahead and work on this on your own for the time being. We'll give you about 3 or so minutes. Try to get those words right. So I'm splitting something up, right? Were you thinking of the standard algorithm? Okay, awesome job. All right, where's that? As you think of another way you can show me. We're going to be moving on in just a minute or two. Grace. I want you to take a second and look at Grace's work. Talk with your partners. What did Grace do? Talk with your partners, not me.
Austin, partial quotient.
Yeah, what did Grace do? What are partial quotients?
They're when you take the original number and you multiply it by like numbers that you think will have the greatest like effect on it.
Effect on it. What do you mean by that?
Like it'll take it down to a low number when you multiply them.
When I multiply the two numbers, it makes it a lower number?
No, it makes it a big number.
Okay.
And then when you subtract it from that number, it'll get you a smaller answer, so you could have smaller quotients.
Who can restate what he's saying?
Like long division.
Like long division? What's partial quotients?
Like long division.
Like long, so that's an example. I want a definition. So what's partial quotients?
It's when you multiply the main number times by another number gets you to the other number.
Your smile's getting bigger and bigger. It's tough to say, isn't it? So I want you to talk with your partners. What's partial quotients? Try to think of a way to define that. Yeah. Quotients. You can give me a definition. You think so? Many have tried. All right, go ahead.
You take the dividend and you multiply it by a number to get the quotient. And you subtract. So, like, if you multiply 32 times 10, you subtract that from, you subtract 320 by 480.
What did she say? repeat that. So everyone's listening. What's partial quotients?
Partial quotients is when you get the dividend and you multiply it by another number to get the quotient. And when you multiply 32 by 10, you get 320. You divide it by the divisor to, and then to get, again, you keep dividing it until you get either a remainder or until you have no remainder.
So who can give me probably about a 1 to 2 sentence summary of that?
I can.
Go ahead.
So basically what she's saying is you divide the dividend by any number that can get it less, like a less number, but and then like a less number to get it to a non-negative number, but then you multiply it, the dividend again, by whatever number, and then you subtract it, and then you
From the whole.
get you subtract the whole, and then you get whatever, like, and then it just keeps going on and on until you get the quotient and then the remainder.
So that's what I call a run-on sentence. But pretty good job. Good job. So looking at this, I'm finding factors I know. Would that be a fair way to say it?
Yes.
And I'm almost using repeated subtraction, but efficiently.
Yeah.
Okay. So as I'm looking at this, partial quotients, I do want to share another one. So the solution that Grace you got was 15? 15 what?
15 stamps.
15 stamps?
Yes. Oh, it's 15 stamps because you said she wants to split them evenly into 32 boxes.
We're good? So this I want to show then is Leslie. I have Leslie's way down here, and I'm looking at that compared to Grace's. And they don't look the same. Take a silent view of what Leslie did. Talking to your partners. What did Leslie do?
She did the same thing, but it was in a different way. She used 3 and 2 instead of 5. But if you add that together, you still get 5. It's just like multiplying 32 but oh my god, times 5, and then if you add that together, I got the answer. So these
Put it back in about 3, 2, 1. So I'm looking at these don't look the exact. They didn't do them the same way. So what's the difference? What do you got?
She just split it up to 5.
She split it up to 5. What does that mean?
She could like divided the 5 in half and like made it like a little bit like a longer way, like a little less efficient way to do the subtraction.
What does she mean a less efficient way for the subtraction? What does she mean by that?
She used a longer version, and Leslie used 2 more steps than Grace did.
So they both got 15 boxes, right? That's their solution? So really, it's kind of the same answer. One was more efficient than the other. Are they both accurate?
Yes.
They both work. Okay. I do want to show you one thing I've seen before. Is it Ashlyn? Ashton? I pulled her paper to show you kind of the same thing. And it looks like it's another way. She did it. She split it up, the partial quotients differently. I do want to show you something I've seen before. And I'm curious what's happening. So hold on. Hold on, be quiet. I've seen a student do this before. Take a second and observe Try to make sense of what this student did silently first on your own. Talking to partners, what did this person do?
Like, she split the box in two and had almost the same thing, just that she didn't have actual questions to do it.
They did 32 times 10 and then 32 times 5 and then added it up.
So what's the box number?
She didn't write it down or he write it down. They probably didn't. It makes sense. Yeah, this is more mental math than it is on a paper. How would they get the 5? They did in their head. Yeah.
So that might be a good question. For someone to say, what did they
The only way they could get the 5 is by dividing by.
All right, 3, 2, 1. What did this person do?
The box method? What is the box method?
You said it. What's the box method?
The box method is just a kind of easier way to divide.
What do you mean it's an easier way to divide?
Well, I mean it's multiply.
What do you mean easier to multiply?
Like,
Ignoring eye contact. You can say I'm not sure. I'm not sure how to explain it, you can say. Or if you want to think on it a little bit more. Okay. Who thinks they can explain what the box method is? Because I heard a lot of people say that. Yeah. Yeah, but this wasn't a multiplication sentence. This was a division sentence.
they're multiplying
So they're multiplying it in a division sentence? Can I do that? Can I multiply in a division sentence? What do you think? Go ahead.
Okay, so what this person is doing,
I didn't ask what this person's doing. I'm asking how do multiplication and division then relate? Can I use multiplication and division?
yes, you could take 32
Uh-huh.
and then times it by 10 and then you'll get 320. And then if you want to do it one more time, then you could do 32 times 5 and then get 160 and then do off subtract off on the side and get the answer.
So you said if I wanted to do 5, so I could stop right here?
Well, you could stop to subtract, but you also have to go back and multiply even more.
Why does he say I have to go back and multiply even more?
because you can't have a sum greater than the 30. So you can't have the answer at the bottom more than 32. You have to get it that's under 32.
So can't is a very strong word in mathematics. Why don't I stop?
Because,
Because I can't do something, usually I can.
well, you're not able to finish because you have to get an answer less than 32.
Because I'm figuring out a quotient, right?
Yes.
So what's the quotient of 480 divided by 32?
Yeah.
If I stop at the 10, does that tell me, have I split up all of my 480s?
No.
Okay, so I have to go until all 480s, or as many as possible are split up evenly. Gotcha. Okay. So I heard this thing, okay, now I want you to tell me. What's the box method?
The box method is where you take the dividend and you multiply it in like a box or a rectangle box, and then you put you multiply it on, and then you put your number, then you multiply it on top of the box to add for later to get the remainder. And so you put the number that equals 32 times 10 inside the box, and then you do 2 times whatever gets less than that number. So you can subtract it, and then once you get the answer, then you do 10 plus 5, and you get the remainder.
Okay. So this box method, have you seen this thing before?
Yes.
When have you seen this before? When have you seen it before?
In 4th grade.
4th grade. When did you do it? What would you do with it in 4th grade?
We had, we kind of did it like this, except we had a few more numbers. So if we had more numbers, then we would split them up like in ones and then ones and we would make boxes so that we would multiply like say 30 times 10. We would do like 300, so we put that in one box. Then we would do 30 times 5, which is 150. Then we put that in the other box.
Did you see it anytime before 4th grade? Where did you see it before 4th grade? When did you see this in 3rd grade?
Like almost at the end of the year,
What did you do with it at the end of the year?
multiply stuff. I mean, divide stuff.
So I'm really good with attending to precision. I'm not going to allow the sentence multiply stuff to be the last thing. So how could we rephrase that? How did you use the area model? How did you use the box method thing? In 3rd grade. You would divide, or I heard multiply. And you would use it for division? How could I have used this in 3rd grade for division and multiplication?
Because multiplication, no, division is the opposite of multiplication. The multiplication is the opposite of division.
Opposite's a tough word. Inverse. Is the inverse of it? Okay. Yeah. You've seen this before, starting in 3rd grade. If you remember, when you used it for division, say I had the problem 32 divided by 8. You used to be able to create a box here, put the 8 here. The inside of the box was 32. And what would go on the top? 4. 8 times 4 is 32, or 32 divided by 4 is 8. Then in 4th grade, you were dividing 4-digit numbers by 1-digit numbers. So I used to be able to do the same thing here. So that if it was, I'd be able to divide it. The same theory. Well, here we have the same thing. So I want to kind of bring some of that terminology together. I've heard this thing called the box method. I've heard it called the window method. I've heard it called the clothesline method. I've heard all these names. But in 3rd grade, you called it the area model. And in 4th grade, it's still the area model. And this model is the area model. So that way, it's the exact same thing. It's nothing new. So if we're referring to this, I'd probably say let's leave out the box method and start calling it the area model, because it's telling me the area of the box. So I have one more question then with what this student did. Why did they choose 10 and 5? Talk with your partners. Why do you think they chose these numbers to split up the area?
You don't need the answer, but you just doing it. If you got
bigger number than 10,
you could just do 32.
If you get a bigger number than 10, it qualifies, but it would be easier to just split up the number into 10s and 1s. I mean, if you get a bigger number than 10, most likely, well, I don't really know how to say this, but I'm not really sure about the times or
Bigger number 10. 32 times 10.
Efficient means fast. So you didn't get this faster than this? No, why is this faster?
No.
That's faster. Okay.
That's
So more efficient. Gonna divide 480 into 32 groups. That'd be a long time, wouldn't it?
But I just don't know how to do for this problem. This question is not good at
try to do like the simpler way, not like the harder way.
So this kind of looks like the harder way now, doesn't it? Because which looks like it may be harder, this or that?
That would be harder.
So let's practice on that.
I mean,
So what did they draw first?
same pretty much.
So have I dividend, right? 32? And where did they put that?
I know you have.
You put it here. How did they put it on there?
Wait, we can't.
Which 32 are we talking about here? The one in the box?
5 times 3 is 8 or the
The one next to the box on the very top. On the left of what? So why don't... Now it looks almost the same as that, doesn't it? Starting off. But then they were choosing numbers. And this is the part we're getting ready to get into, of why they chose that 10. So I want you to listen into why they're choosing the 10. And that might be why to choose it. Okay? Thank you. Alright, bringing it back. Why do you think they chose that 10? Yeah.
Because you could just add up this value, which is 320, so you would already know it really quick.
What do you mean you already know it really quick?
Well, you just could add a place value to 32, which is 320.
Add a place value. What does he mean by that? Add another 0. So I had 32 and I added 0, which gave me the 320. Huh? So 32 times 10. And what am I doing? So 32. And I'm adding a 0 when I multiply it times 10. And that gives me 320. Is that right?
No.
I added a 0. Do I write the word place value? What do you mean add a place value? What does he mean? Yeah, but I added a 0 to the 32 and it gave me 320.
No, you don't add a 0. You
Add a 0?
get 32 times 1,
Uh-huh.
and then you get 32, and then you put
This is another thing that started about 3rd grade. You know, it's sometimes hard to put in the words, so I want you to be precise in what you're saying. I like how you're referencing place values. That's true. How can I phrase that so that it's not just add a 0? Did I add a 0 here? Yeah, I added a 0. So what do you think? Shift the place value. What does she mean shift the place value? Is that what you mean? I shift the decimal point? Is that what I do when I multiply times 10? No? Yes and no? One or the other? Yeah. Is that a question or an answer? You give it a shot? Go ahead.
Yes, the decimal point is still there, even though you don't see it. But when you multiply it by 10, it's shifting the place value to the right, so it's a bigger number.
Okay. So I'm increasing the value by how much? 10. So how many would 3 tens be? How many 32 tens would be? So 32 times 10 is? So 32 tens is? Okay. So I can calculate those tens usually pretty quickly. Right, I like the place value part of that. Okay. So I'm looking here. This is called the area model. What did they do? Okay. So looking at the area model here, how does that connect to what you were doing with partial quotients? How does this method connect to what you've already done? Talk to your partners. How does it connect?
It's almost like a partial quotient except it's using boxes. Yeah, it's just using box to break down the number, so it's easier for them to put it in it's just a different method than partial quotient. It's just a different way to learn it.
Oh, and I also noticed when they're
And now, this is your first time seeing this, what division now? For division this year?
No, we've done this in third and fourth grade.
Okay, but this is the first time in 5th grade, right? Yeah. Okay, because this thing's here ready to pick up steam in just a minute. So I want to make sure you fully understand this. How are they connected? How are these two ways connected?
They're like the same thing, but just different methods of doing it.
Okay.
Like, some people might think that one of them is easier than the other one, but you're just putting the numbers in a different way to add them up and get the product.
Okay, so it seems like we're almost there with it. Look at the numbers involved in the area model. What do we say? 320, 320, 160, 160. Why would somebody want to use this method instead of this method? What do you think?
Because it's easier for them.
Why would it be easier for them?
Because they might not be able to do division. They wouldn't be able to do division in like their head. They have to write it down, or they have to
You say I'm not sure. Okay. So hold on, put your hands down for just a minute. All right. So where we're going with this, really wanted to dig back and review kind of what you've done with this before. Because you've used this before, and the area model is going to be coming back. So we're going to find out. We've used partial quotients. We've heard the standard algorithm was also used. We want to really dig into this method now to see how this works so that I can figure out if it's an efficient way or not. Maybe sometimes I'm going to want to use the area method depending on the numbers in my dividend. Okay? So moving forward, I just want to do a quick summary because we talked about your learning goal today was really focused in on the division of multi-digit numbers by 2-digit divisors. And we're going to build our way up to 4-digit by that. We explored the area model. What do you guys think about this method? do you think about the area model for division?
It might be trickier for us because we are just now starting it.
Okay.
And it's different. And it's different because we're not really used to it.
Okay. So it could be a challenge starting off. Okay. What do you think?
I say it's a lot more complex.
Why?
And it's a little bit more steps because so how we did partial quotients is a little bit more simpler because all you have to do is just multiply in your head, know the number, subtract it instead of writing all of the boxes and doing it just you actually, when I was in 4th grade, I always used to think that this was hard.
Mm-hmm. So would you say it's hard?
I'm not, like, there used to be 4 sections instead of just 2 like this.
Okay.
And so I used to always get messed up because I don't know where to put like each number inside the little teeny boxes.
Oh, okay. It's interesting. So it sounds like you've got some errors to pay attention to as you're moving forward with this strategy.
Yeah.
So maybe we need to look at when are efficient times that I should use this strategy, and maybe when are times I shouldn't. All right, I do have to wrap this up. So you guys are awesome. My favorite, no, I don't want to say that because I know the other 5th grade class too. You two were the favorite 5th grade classes that I've met with ever. So I just want you guys to say, go math.